Hello everybody, here I will discuss an exam question that uses the sine and cosine rule. A soccer player aims towards the goal, which is 15 meters from the back line, CH, on a soccer field. The angle from the left goal post EFG to the soccer player S is 116 degrees. The goal posts are 7,32 meters wide. The diagram represents the above situation. Calculate how far the soccer player is from the left goal post FG. In other words, we are looking for the length of SG. Now, first of all, do you agree we can work out the size of angle G1? And we can do that by saying G1 plus angle SGH is 180 degrees. That's the 116 degrees angle. And the reason we can say they are 180 degrees is CH is a straight line. So they are angles on a straight line. Into SGH's place, I substitute 116, its size, and therefore G1 is 64 degrees. And remember, once you know the size of an angle, fill it in on your sketch. Again, what was the question? The question was, we need to find the size, or the length rather, of SG. How far the soccer player is from the left goal post, FG. Now, can you see that we are working in the right angle triangle CGS? And when we're working in a right angle triangle, we use normal sine, cos and tan. So the ratio that's going to work here, the function is sine. The sine of G1 is, remember, sine's ratio is opposite over hypotenuse. Therefore, CS over GS. And then into G1's place, you can substitute the 64 degrees equals CS is 15 over GS, the one you're looking for. You manipulate your equation, you make GS the subject of the formula, you slot that into your calculator, and the answer, GS, is 16,69 meters. The next question, how far the soccer player is from the right goalpost EH. Now there's EH. Can you see on the sketch, in the previous sum, I worked out the length of SG, so I added it on my sketch. Now, how far the soccer player is from the right goalpost EH, that means I'm working out SH's length. And you will be working in the non-right angle triangle SGH. And if you look at the sketch, can you see the information? You've got that length of SG, it's 16,69. You've got this length of GH, 7,32, and you have angle G, 116 degrees. Can you see it's two sides and the included angle? Therefore, you're going to use the cosine rule. Remember, I said two sides included angle is always the cosine rule. Therefore, in non-right angle triangle SGH, we can write the cosine rule. SH squared, the one we're looking for, is equal to GH squared plus SG squared minus 2 times GH times SG, the cos of 116 degrees. And we substitute. SH squared is equal to 7,32 squared plus 16,69 squared minus 2 times 7,32 times 16,69, the cos of 116 degrees. You slot that into your calculator and you get SH squared is 439,2508, etc. Remember, don't round off here. You keep that whole number. And then to find SH, you take the square root, and SH's length is 20,96 meters. And you can fill it in on your sketch. The next question, the approximate size of angle GSH is that one. The angle within which the soccer player could possibly score a goal. Again, we are working in the non-right angle triangle, and now we will work with the sine rule. So in triangle GSH, we find the sine of S2 over GH. Let me just show you this one. I labeled it S2 is equal to the sine of G2, which is the 116 degrees. Let me show you. This is G2 over SH, the one we just calculated. And we substitute. Sin S2 is equal to G2 is 116 degrees, so it's sin 116 times GH was given 7,32 over, and SH was 20,96. But remember, you are calculating an angle now, so it is second function or shift sin. All of that equals, and therefore the size of S2 is 18,29 degrees. In the next lesson, I will discuss another exam question where we will use the area and the cosine rule. Click on the video in the left-hand corner to take you straight to the next lesson.